Last but not least, we have determine the value of theta with our calculator. So let's get started. 13 and 14, I noticed that it says determine the values of theta where theta is between 0 and 360. So we're going to make sure that our calculator is in degree mode. So change that to degree mode right away. And we're going to round to the nearest tenth of a degree. I noticed that on the last test, some of you guys didn't pay attention to how many points or decimal places you should be rounding to. So just checking to see if you're paying attention to the directions here. So we're going to figure out, determine the values, plural, and sketch where the terminal sides, plural, lie. So that should tell you that you're going to have two. For this one, we're going to have two values. All right, now number 13. I can't type that into my calculator the way it looks because my calculator doesn't have an equals button. It has an enter, but there's no, it gives me a value. It doesn't show as something equals something. So that tells me that I need to rewrite this so that I can put it into my calculator. I'm solving for theta. I'm finding theta. So I need to separate these two. To separate a trig function and a value of theta, you use inverse operations or take the trig inverse of that value. So we're going to say that theta equals the trig inverse or the cosine inverse of this value, 0.8924. Can I type it into my calculator now? Yes, I can, because I have a function that gets me to cosine inverse, second cosine. Notice how cosine has cosine inverse written right above it. Cosine inverse of 0.8924. It looks exactly like what's on my paper, so I know I'm doing something correctly. My theta that's given to me is 26, the 10th of a degree, so 26.8 degrees. I'm only halfway there, 26.8 degrees. Where is it? Sketch the terminal side. It's in the first quadrant between 0, my initial side, and 30 degrees, the first point. So this is theta 1. Now, one step that I used to do, I did with you guys on your homework or your classroom notes, was first thing that I noticed was that the value is positive. I should know that there's going to be two sides. Where are those two sides going to be? Okay, well, if the value is positive, where is cosine positive? If cosine is x, x is positive in the first and the fourth quadrants, not the second and the third. So that means that I can fold my unit circle so that I get my other terminal side that's symmetrical to the one in the first quadrant. So my theta 2 is, I'm not sure yet. I know that the distance from my x-axis to my first terminal side was 26.8. If I'm trying to find between 0 and 360, that means I have to go all the way around to get to my second theta. And I almost get to the 360. If I went all the way to 360, I would go too far. So I'd have to go back by the same distance. Your reference angle is always the same. It's always going to be the same value. So for this problem, the reference angle will always be 26.8. So if I went all the way to 360, I went too far. I need to go back by 26.8. And if I'm going back, I'm going to subtract. And 360 minus 26.8 gives me 333.2 degrees. That is my second theta. For number 14, trouble. Okay, first thing that I notice is that it's cotangent. I know that cotangent is 1 over tangent. So that means that tangent is 1 over cotangent. And these are all talking about the values of these trig functions. So the value of cotangent is 1 over tangent. The value of tangent is 1 over cotangent. If I have the value of cotangent, to find the value of tangent, I take the reciprocal of that. So tangent is 1 over negative 4.4637. I still can't type it into the calculator the way it looks because, again, there's no equal sign. There's no theta button. There's a button that has theta on it, but that's when you're typing it into y equals. So I need to rewrite this. I'm solving for theta. I need to separate tangent and theta. To separate them, I use inverse operations. Take the inverse of both sides. So tangent inverse of 1 over negative 4.4637. I can type it into the calculator like that. That looks pretty good. So I'm going to type it in. Tangent inverse. Second tangent. Notice how it has tangent inverse above. Of 1 over negative 4.4637. That looks pretty close to what I have here. It's just not vertically aligned with the fraction. But other than that, it's exactly what I have on my paper. They give me a theta of negative 12.6 degrees. Now, I always say, what's wrong with this? It's negative. I can't have negative theta. So first, let's figure out where negative 12.6 degrees is. It's in the fourth quadrant, not quite to that first dot yet. So if I want positive degrees, if I want positive degrees, I know that this distance is 12.6. So if I were to go all the way around, I would almost make it to the 360. Almost to 360 degrees, but not quite. I'm not there yet, so I'm less by 12.6 degrees. And 360 minus 12.6 is 347.4. So a coterminal angle to negative 12.6 is 347.4 degrees. Remember, there's two different places that this could happen, that this value of cotangent could exist. So let's go back. I notice that my value of cotangent is negative. So because of that, cotangent is negative in the fourth quadrant, but not in the first and not in the third. So that means it's also negative in the second quadrant. To figure out where that angle is, your reference angle is going to be the same and it's symmetrical, so it's going to be close to the x-axis. My reference angle from the x-axis to my terminal side is again 12.6. If I were to figure out my displacement, it's almost to the 180, but not quite. It's less than 180 by 12.6. So 180 minus 12.6 gives me an angle of 167.4. So my theta 2, 167.4 degrees.